In this video we introduce a series of formulae known as the factor formulae, which are consequences of the compound angle formulae. So, the compound angle formulae we have met already for sine of p plus q, sine of p minus q, cos of p plus q and cos of p minus q, and they're presented here as equations 1, 2, 3 and 4. If we add these equations 1 and 2, we're going to obtain sine of p plus q plus sine of p minus q is equal to 2 sine p cos q. Similarly, if we do a subtraction of equation 2 from equation 1, we get sine of p plus q minus sine of p minus q is 2 cos p sine q. If we add equations 3 and 4, we're going to get cos of p plus q plus cos of p minus q is 2 cos p cos q. And if we subtract equation 4 from equation 3, we get cos p plus q minus cos of p minus q is equal to minus 2 sine p sine q. Now these new equations, equations 5, 6, 7 and 8, can be useful when we wish to express a product of trigonometric functions as a sum or difference of two trigonometric functions. And one example where we might want to do that is in integration. So we want to try and evaluate the integral between 0 and pi by 8 of sine 2x cos 4x. Now if we look down the list of formulae that we've just introduced, you'll see that equation 5 tells me that 2 sine p cos q is the same thing as sine of p plus q plus sine of p minus q. So we can say, making use of that formula, that 2 sine 2x cos 4x is going to be the sine of 2x plus 4x plus the sine of 2x minus 4x. So therefore sine 2x cos 4x is going to be a half of the sine of 2x plus 4x plus the sine of 2x minus 4x. So that's the same thing as the half of the sine of 6x plus the sine of minus 2x, but the sine of minus 2x is simply minus the sine of 2x. So we've got sine 2x cos 4x is the same thing as a half sine 6x minus sine 2x. So we can say that the integral that we're trying to work out is the integral between 0 and pi by 8 of a half sine 6x minus a half sine 2x. Doing the integration, we get minus a 12th cos 6x plus a quarter cos 2x. And we want the value of this when x is pi by 8, and then to take away the value when x is 0. So we've got minus a 12th times by the cos of 6 pi by 8, which is the cos of 3 pi by 4, which is minus root 2 upon 2, plus 1/4 times by the cos of 2 lots of pi by 8, which is pi by 4, so that gives me a quarter of root 2 upon 2. Take away the value when x is 0, which is going to be minus a 12th cos of 0, which is minus a 12th, add a quarter times cos of 0, which is a quarter. So simplifying that, we've got root 2 over 6 minus 1/6. So I've got root 2 minus 1 over 6 as the value of the integral. Now, the factor formulae are an immediate consequence of equations 5 to 8. We shall see this in a minute. So we're going to write a as being p plus q and b instead of p minus q. Now if I've got a equals p plus q and b equals p minus q, now I've got a plus b is 2p, so p is a plus b over 2, and similarly a minus b is 2q, so q is a minus b over 2. So what's this do to the factor formulae? Well, equation 5, if I substitute for p and q, is going to become sine a plus sine b equals 2 sine a plus b over 2 cos of a minus b over 2. Similarly, sine p plus q minus sine p minus q equals 2 cos p sine q is going to become sine a minus sine b equals 2 cos a plus b over 2 sine a minus b over 2. Cos p plus q plus cos p minus q equals 2 cos p cos q is going to become cos of a plus cos of b equals 2 cos a plus b over 2 cos a minus b over 2. And then finally, cos p plus q minus cos p minus q equals minus 2 sine p sine q becomes cos a minus cos b equals minus 2 sine a plus b over 2 sine a minus b over 2. Now these are the factor formulae. So equations 9, 10, 11 and 12 are the factor formulae, and you'll be pleased to hear that they're actually given in the formula booklet that you'll be given for use in your exams. So let's have a look now at how we can use them. They're particularly useful when we've got equations to solve where it is useful to convert a sum or difference of trigonometric functions into a product of those trigonometric functions. So let's have a look at a couple of examples. First example then, we're going to try and find the general solution in radians of the equation sine 9x minus sine 5x equals 0. Well, we've got the factor formulae down at the bottom of the page. We can see that sine a minus sine b is 2 cos a plus b over 2 sine of a minus b over 2. So, using that result, I can rewrite sine 9x minus sine 5x as being 2 cos 9x plus 5x divided by 2 sine of 9x minus 5x divided by 2. In other words, 2 cos 7x sine 2x. So my equation sine 9x minus sine 5x equals 0 can be rewritten as 2 cos 7x sine 2x equals 0, which means that I know that either cos 7x is equal to 0 or sine 2x is equal to 0. Now I know that cosine of pi by 2 is 0. So I've got really in red the equation cos 7x equals the cosine of pi by 2. General solution of that will be 7x equals pi by 2 plus 2k pi. In other words, or 7x equals minus pi by 2 plus 2k pi, which in turn gives me x is plus or minus pi by 14 plus 2/7 of k pi, where k is an integer. Now for sine 2x equals 0, I know that sine of nothing is nothing. So I've really got the equation sine 2x equals sine of 0. And that means that I've got that 2x is either 0 plus k pi or pi minus 0 plus 2k pi. In other words, I've got 2x equals 0 plus 2k pi or pi plus 2k pi, which gives me x is either k times pi or pi by 2 plus k pi. So my general solution to the equation is x is plus or minus pi by 14 plus 2/7 k pi, or x equals k pi, or x is pi by 2 plus k pi, where k is an integer. Now for our next example, we're going to try to find the general solution, again in radians, of the equation sine 2x minus sine 6x plus sine 10x equals 0. Now again, the factor formulae will help us, but it's not immediately obvious which form of the factor formulae to use. We might be tempted to start off by considering the sine 2x minus sine 6x part of the equation, and using the factor formulae we can rewrite sine 2x minus sine 6x as 2 cos 4x sine of minus 2x, or in other words as minus 2 cos 4x sine 2x. And if I made that equivalence, then my equation would then become minus 2 cos 4x sine 2x plus sine 10x equals 0. And to be quite frank, I've got no idea how to proceed from that equation. It hasn't helped me simplify the original equation. So I'm going to throw that bit away. I'm going to have a look instead now at what might happen if I think about the sine 2x plus the sine 10x. Now sine 2x plus sine 10x can be seen using the factor formulae to give me 2 sine 2x plus 10x over 2 cos of 2x minus 10x over 2. In other words, 2 sine 6x cos of minus 4x. But cos of minus 4x is the same thing as cos of 4x. So I've got sine 2x plus sine 10x is the same thing as 2 sine 6x cos 4x. So the equation sine 2x minus sine 6x plus sine 10x equals 0 can be rewritten as 2 sine 6x cos 4x, which is the rewrite of the sine 2x plus sine 10x part, minus the sine 6x equals 0. And hopefully you can see now why this is such a good move, because we've got a factor of sine 6x. So I've now got sine 6x times 2 cos 4x minus 1 equals 0, which tells me that I've got either sine 6x equals 0 or cos 4x equals a half. Sine 6x equals 0. Well, I know that 0 is the sine of 0, so I've got basically there sine 6x equals sine 0. So that tells me that I've got 6x is either 0 plus 2k pi or pi minus 0 plus 2k pi. In other words, that's telling me that I've got x is k pi by 3 or pi by 6 plus k pi by 3. For cos 4x equals a half, I know that a half is the cosine of 60 degrees, or in radians, it's the cosine of pi by 3. So I've got cos 4x equals cos of 4 pi by 3. So that tells me that 4x must either be pi by 3 plus 2k pi, or minus pi by 3 plus 2k pi. And dividing through by 4 gives me x is plus or minus pi by 12 plus k pi divided by 2. So the general solution to the equation is x is k pi by 3 or pi by 6 plus k pi by 3, or x is plus or minus pi by 12 plus k pi by 2, where k is an integer. And for our final example, we've got to prove that cos 10x minus cos 4x divided by sin 10x minus sin 4x is equal to minus tan 7x, and hence find the general solution, this time in degrees, of the equation cos 10x minus cos 4x divided by sin 10x minus sin 4x is equal to root 3. We've got the factor formulae available again to us. So using the factor formulae, cos 10x minus cos 4x using the bottom of the four formulae is the same thing as minus 2 sin 7x sin 3x. And then sin 10x minus sin 4x is, using the second of the four factor formulae, the same thing as 2 cos 7x sin 3x. And this means that I can now rewrite cos 10x minus cos 4x over sin 10x minus sin 4x as minus 2 sin 7x sin 3x over 2 cos 7x sin 3x. The 2's cancel, the sin 3x's cancel, so I'm left with minus sin 7x divided by cos 7x, in other words, minus tan 7x, as required. So the equation cos 10x minus cos 4x over sin 10x minus sin 4x equals root 3 can be rewritten as minus tan 7x equals root 3, which means that tan 7x has got to be equal to minus root 3. Now, minus root 3 is the tan of minus 60. So I've got tan 7x equals the tan of minus 60, which means that 7x must equal minus 60 plus k times 180. So x is 1/7 of minus 60 plus k times 180, where k is an integer. So here's an exercise which will enable you to just practice using the formulae that we've met during the course of this video, and perhaps you'd like to have a go at these questions, or at least a few of them, before your next lesson. And that concludes our work on the factor formulae.